Beautifully, you can see the S11. S11 is your reflection coefficient at 1.8. You see the reflection coefficient is very, very minimum. It is close to minus 5.5 dB. Okay, so the reflection is very, very minimum at 1.8 gigahertz, which is our frequency of interest. Okay, so S11 we have seen, and you have an option called tile. You have an option called tile. You can see everything together. Instead of having in separate windows, if you use the style option, you can see all the plots in a single design in the single designer app. Now, in the scalar frequency analysis, click the current. So, if you want to view the current distribution, click the current tab here. You can see the current variation in the helix. You can rotate and see in 3D. I think you are able to see how I am rotating. You can rotate the antenna and see how it is happening in 3D. Current distribution. This is the top view. This is the side view of the helical antenna. Okay, the side view will look like a sinusoidal wave. The top view will look like a circle. Okay, this is the top view, and this is going to be the side view of your helical antenna. This was the view which we were talking about, and this is the current distribution, amperes per meter. So you know the current distribution is very high in the plate below, and the current slowly travels through the helix and gets propagated as electromagnetic waves. See how antenna design is very, very simple using MATLAB. So it is very, very simple. You can also click on 3D pattern, all the other things. You can click on 3D pattern. This will give you the radiation pattern of your antenna. You know what is radiation pattern? Direction along which you have your maximum radiation. You see, whenever the helix along the helical axis, you will have maximum radiation. This is your major lobe. You have so many minor lobes here. Okay, at the major lobe, you see you have peak power 10 dBi. Major lobe, you have 10 dBi peak power. Across the minor lobes, you have close to minus 5 dBi. So you cannot have an antenna which is perfectly having only radiation along the major axis, right? So you have you have the minor lobes also existing here, which will contribute to your noise. Okay, so this is the radiation pattern. Azimuth and elevation pattern. Azimuth, you know, azimuth, this angle when you move the antenna from the sideways. You rotate your head from left to right, that is azimuth. Azimuth can be from minus 180 to azimuth is for 180 degrees. You can rotate your head. You cannot rotate your head 360 degrees, right? So azimuth means it is from your left to your right or from your left to your right to your left, you're rotating head. So it covers 180 degrees. That is your azimuth angle, and elevation angle is you're rotating your head from top to bottom. That is your 180 degrees. So this is the plot you're having for elevation. When you consider elevation, azimuth is 0. When you consider azimuth, elevation angle is 0. So you can see what is the plot. The horizontal plane, azimuth is the horizontal plane, okay? Azimuth is the horizontal plane, and elevation is the vertical plane. You see along the helical axis, you will have made this is as it is vertical, but azimuth you have to view it in a horizontal pattern. Okay, that is your horizontal pattern. Okay, so all the properties of the antenna you can design everything, and you can change. Once you change everything, you can redo the simulation, and you can see what parameter, whether it is changed or not. You can perfectly do that, and you also have an option called